Hello friends, I am Rajaneesh or Chandran. So welcome back to my YouTube channel. In this video, we are going to study about the projection of lines inclined to both the planes. So far we have learned projection of lines which are parallel to both HP and VP, projection of lines perpendicular to one of the reference planes and parallel to the other, and then we have learned projection of lines inclined with HP and parallel to VP and projection of lines inclined with VP and parallel to HP. Actually these three projection of lines parallel to both the planes, projection of lines perpendicular to one of the reference planes and parallel to the other, projection of lines inclined to one of the reference planes and parallel to the other are called projection of lines in simple positions, because the line is parallel to one of the reference planes in all these conditions. And now we are moving to projection of lines inclined to both the planes. So in the university examination point of view, actually your engineering graphics, the topic or the subject engineering graphics actually begins with the projection of lines inclined to both the planes. The questions will be asked only from these portions in projection of lines. So what we have learned before the projection of lines inclined to both the planes are actually introductory topics that we are required for learning this projection of lines inclined to both the planes. Listen, this is HP and this is VP. Now you can see that this is a line. That line is inclined with both HP and VP, right? You can see an inclination with the VP like this, and you can see an inclination with the HP like this. See, this is the inclination with the HP. So, in the previous video, we have learned the true inclination of a line with respect to a plane, right? What do you mean, or what do you understand by the term true inclination of a line with respect to HP or VP? True inclination of a line is the inclination of the line with respect to a plane. See, now you can see that this is HP and this is a line. This line is inclined at an angle, this amount from this plane, right? So how that angle can be calculated? For calculating an angle of a line from a plane, the important thing is we have to assume a plane containing that line. This line, assume a plane containing this line perpendicular to this line. So if this is the line, if we have to consider a plane like this, and along that plane we have to measure the angle. That angle is known as the true inclination of the line with respect to the plane, or with respect to this HP. Suppose this line is inclined like this, the plane containing that line will also tilted like this. So that now this is the plane perpendicular to the line. So in this case we have to measure like this only. This angle is known as true inclination of a line with respect to a plane, or the inclination of a line with respect to a plane. At the same time, see, this line is like this. This will be projected on VP. This point also will be projected on VP. So at the same time, when you are observing this line from infinity, you can see that this projection like this produces an angle with respect to this XY line, right? This is the projection, and this angle is known as apparent inclination. So we are now learning a new term which is called apparent inclination. So what is apparent inclination means? When we are observing a line, the line will be projected on the corresponding plane, and that projection will make an angle with respect to the XY line or reference line. That line is known as apparent inclination, and the other one that what we have explained previously is known as true inclination. So true inclination is the inclination of the line with respect to the plane, whereas apparent inclination is the inclination of the projection of the line with respect to the XY. The two true inclinations we have learned in the previous videos. So true inclination with the HP is indicated with the theta, true inclination with the VP is indicated with the phi. Both the true inclinations can be observed along with the true length of the line. If the line is showing the true length, the inclination will be true inclination. Then what is apparent inclination? Apparent inclination is the inclination of the projection of the line apparent inclination, the inclination of the front view of the line is known as apparent inclination with HP and is indicated as alpha, and apparent inclination is the with VP is the inclination of the projection of the line on the top view. So the top view will be inclined at an angle that with XY line, and that angle is known as apparent inclination with VP and it is called beta. So that are alpha and beta. The projection of lines inclined to both the planes can be done in two ways. One method is known as rotating line method and the second one is known as rotating plane method or trapezoidal method. In this video, we are concentrating only on the rotating line method. See, this is a line. This line is now inclined with both VP as well as with HP. You can see that the line is inclined with VP as well as with HP. We have to make the projections of this line using rotating line method. The method is, see, this is a line. In rotating line method, what we are doing is, we fix one end of the line at a point and rotate the other end of the line like this and make this line parallel to one of the reference line. Since you are watching or observing from its front, the easy thing for us to understand is make parallel with it. See, this was the position of the line. We rotate this line and make parallel with the VP. And there is a condition for the rotation. The condition for rotation is, see, we are rotating about this, rotating this point, right? We are fixing this point and we are rotating this point. So the height of this point or height of elevation from HP. See, the height of, if this is HP, the height of this point from HP should keep same or constant while rotating. That means this height will be same while rotating the line. So keeping the elevation height or the height of the front view of this point constant and keep this point fixed, we can rotate this line from any position and we can make this line parallel to VP. So you can see that now this line becomes parallel to VP. And we know that when a line is parallel to one of the reference planes, the projection of the line on that plane will give the true length. So since we made this line parallel to VP, at this point you can see the true length of the line. You can see the true length of the line, and in the opposite projection, since this is true length, we know that its opposite projection will be a line parallel to XY. So I hope all of you have understood this much portion. So the line was in an arbitrary position or in a position which is inclined to both the HP and VP, and now after rotating, the line becomes like this. We can name this as a B1 dash, that I will explain later. So since this is A dash B dash, now this is showing the true length because this is a position when the line is parallel to VP. So it's opposite projection A, B. So this is the position of the line when it becomes parallel to VP. See, this is the position of the line. We have fixed the line here and we have rotated this line by keeping this height constant like this and make a parallel with VP, right? So what will happen to this point? We know that since the height of elevation is constant, this point will be moving along a line. See, this was the initial position and we are rotating into this position by keeping this height constant. That means that when we are observing this process from infinity, we can see that this point will projected here, and while rotating this line like this, since this height is same, so this point can be observed as moving along a line as this height is kept constant while rotating. So this point will be projected here at this position, and while we are rotating this line like this point will be moving along a line like this. That line is known as the locus line of this endpoint. That line is known as the locus line of this endpoint. So we can name this as locus line of B dash. If this is the point B, this can be named as locus line of B dash. I hope all of you have understood. So this is the fixed point A dash, and the point B dash will be moving along this line like this. And at a point, when this line becomes parallel to VP, this length will become the true length, and at this point will be the part of this line at a true length or at a parallel to VP. So that point, so now this is a true length, and that point can be represented as A dash B1 dash. So this is projection is A dash B1 dash, and this point is B1 dash. And we know that at the same time its opposite projection will be line parallel to X. So this much portion has been complete. Now see, this was the line, this was its fixed position, and this was the initial point of the point B of the line. And we are rotating and make a parallel with it, right? What will happen to its top view when while rotating this line? We know that this point will be projected on HP, this point also will be projected on HP. What is that projection? That projection will be the top view of this line, right? So when we are observing from top, this point will be projected on HP, this point will be projected on HP, so that we will get a line. And that line will be the top view of that line. And when it is moving back to the original point, you can see that its top view will produce an arc like this. That means in the top view you can see that an arc like this. An arc like this. That will be moving like an arc like this. That means if this was the initial position, while rotating this line like this point will produce a top view here, this point will also produce a top view here, and we have top view of the line, and that top view of the line, suppose this is the top view, that top view of the line will produce an arc. These are the basic things you have to understand. So if this is the line, if this is the position of the line, keeping this point fixed, we can rotate this line and make this line parallel. So as I told, this position, we can see that the point can be moved along the line. That line is known as locus line, and at the same time in the top view we can see that keeping this point as center, this projection produces an arc like this. So in the top view the point B moves along this arc, and in the front view the point B dash will move along the locus line. Suppose in the question if there is a provision for obtaining the locus line of B, that we can discuss in the exercises. We can, from this position we can obtain the projection AB. See, this we can discuss in the exercises that we will discuss in the next video. So now we have obtained the projection AB, project B, draw the vertical projector from B, that will meet the locus line of B dash here. So this will become our B dash. So that now we have obtained the projection A dash, B dash, and the projection AB. So now the position of the line, the projection of the line AB, which was inclined with both HP and VP, has been obtained. So this is the method of obtaining the projection of a line using rotating line method. So once we completed the projections, we have to measure the four angles. The two angles, that means true inclination with the HP and VP, and the two apparent inclination, that means the inclination of the projections of the line A dash, B dash, and AB with the XY line. These are known as apparent inclination. So we have to measure both the true inclinations theta phi and the apparent inclination alpha beta, and we have to also measure the length of the front view A dash, B dash, length of the top view AB. This is actually the problem that will ask in the rotating line method. So we know that all the true length lines will have true inclinations. So here this is the true length, and since it is A dash B1 dash, it is the true length in the front view. So since it is the true length in the front view, this inclination will be the true inclination with the HP. So this will be the angle theta. So theta is the angle of inclination of the true length in the front view, or the angle of inclination with the HP. So theta is the inclination of A dash B1 dash with the XY line, and this is the inclination of A dash B dash. Inclination of A dash B dash means it is the inclination of the front view. That is called alpha, apparent inclination with the HP or XY line. Apparent inclination of the front view with the XY line, or apparent inclination of a line with the projection with the HP. This angle is angle of inclination of AB, top view with respect to XY line, and that is indicated with the beta. Now we have to calculate one more data from this projection, that is the true inclination of the line with respect to VP or phi. See, this is the true inclination of the line with respect to HP, because this is the angle of inclination of the true length in the front view with respect to XY line. Similarly, if we are able to obtain the true length in the top view, that inclination with the XY line will be the true inclination of the line with respect to VP or phi. So how can you obtain the true inclination of the line, true length of the line with respect to VP? It is very easy. Now we have the true length. Take this value, keeping A as center, intersect an arc here in the locus line of B. Because as I have told, we can rotate this line by keeping this point fixed and make parallel with the VP. The same process can be done by rotating this line and we can make parallel with the VP also. At the same time, all this process will get reversed. Okay, so if we are doing like that, we can obtain the true length here in the top view. So the process is, take this true length, keeping A as center, intersect an arc. That will be our second true length, name it as B2. So this will be the true length. We know that for a point, two projections will be there. One is its top view and another is its front view. Since we have obtained B2, we have to mark B2 dash also. That is the projection in the front view. So since this line shows the true length, its opposite projection will be a line parallel to XY. So this is A B2, its opposite projection is A dash B2 dash. So since it is a parallel projection, B2 dash will be here. And if you draw an arc like this, clearly this will be here. Clearly, because this is the true length, this is its opposite projection, we have rotated here. Similarly, this is a true length, this is its opposite parallel projection. If we rotate it, clearly it will meet here. That's the property of a rotating line method, or that is a property of a projection also. So now we have obtained the true length in the top view, so that angle will be the true inclination of the line with respect to VP, that is phi. So this is actually the concept of rotating line method. Actually, this is a very easy thing, and if you feel some difficulty in understanding this concept of rotating line method, leave that in this video, no problem, because in the next video we are going to discuss the same rotating line method with the help of an example. So while doing that example, clearly you will understand this concept as well as the working method for doing or conducting the projection of lines using rotating line method. So there are a lot of step-by-step approaches, and if you can understand that step-by-step approach that I will explain in the next video with the help of an exercise, clearly you can understand this rotating line method. So in rotating line method, the angle of A dash B1 dash, that means that the true length in the front view will be theta, angle of A dash B dash will be alpha, that is apparent inclination with the XY line, angle of AB2 or the true length of the line with the VP is phi, and angle of AB, that is the top view, is beta. So I hope all of you have understood this concept, and in the next video we will discuss the rotating line method with the help of an example. So I think all of you have understood the concept and introductory topics related to projection of lines in both the planes using rotating line method. In the next video we will see the same rotating line method with the help of an example. So we can see in the next video. So please subscribe my channel if you like my video. So we can see in the next video.